VK. I am here with my colleague Varun, and we have another author who is not here, Ameya. So we'll be discussing on vision-powered RAG agents for organizational software and web operations. Yeah. So basically, we'll start with the introduction, why we went into web automation, then what are the challenges we face into this task, the contributions, the agentic workflow, how we build and how we build the complete architecture, its components, the results, and finally the remarks. So initially, like why we begin this task, like especially into the organizational context, we need to do lots of day-to-day tasks in web operations, considering like applying the leaves or filling maybe agile tickets or something similar. So now what happens is for that, as an employee, we need to train them and we need to follow multiple documents from them. And then these are basically very monotonous and routine tasks which needs to be done on day-to-day basis. So it actually consumes a lot of time of employees. So first objective was to improve the efficiency into these routine operations. Then most of these operations are well documented in almost every organizations. So we can use this documented knowledge to automate the process. And generally, historically, this kind of operations were carried out using RPA, robotic process automations. But now those are very static and hard-coded. So we wanted to make it a little more dynamic so that we can handle all these portals which are getting updated periodically. And then also the basically user can just give the query in natural language and it will handle that as well. And of course, reduce or eliminate the trainings from that one. So with this as a motivation, our objective was to develop the autonomous agent, so which will understand the user query in the natural language, and then it will execute the task in both web and software automations. So here on for the paper presentation purpose, we are showing the web automation as application. So now the challenges is like these web pages are especially designed for human as a user. All the graphics, all the context and everything. So whenever we want to put it for the agent to make it work, so first of all, it has to understand the user query and then what would be the probable output from that one. Then understand the entire complex web structure. So nowadays, because of this multiple graphical contents and long web pages, it is getting more and more complex to understand the entire web structure from autonomous point of view. And then after understanding everything, agent has to generate the plan to carry out the desired task. For example, I'm saying it to say apply leave from this date to that date with say casual leave. So now it has to first understand the entire web portal. Then it has to go to those, go to the next page, then again understand the next page entire web structure. And there could be some pop-ups and then drop-downs and everything it needs to fill. Then complex navigation as well, because if sometimes the pop-up comes or the cookie approvals or even the language settings can be different, which needs to be changed. So this basically comes as a pop-up and which could be slightly difficult to handle in autonomous way. Obviously, these are very easy as a human, but for the agents, it could be difficult. And since they rely on underlying LLM models, those are trained on public open data sets. And especially for the agents which we are developing for the internal web pages, that knowledge is not available for the LLM agent. So we need to integrate our own knowledge into the agent and then utilize it for the application. So this is one, so generally in the literature review like Web Voyager or Agent-E or Web GPT. So to understand the web page structure, they generally follow two approaches, the HTML parsing, which can be noisy because the HTMLs can be very long, and to understand the entire HTML through parsing can be error prone, or you may not even extract all the clickable elements from the parsing operation. The next thing is obviously screenshots, and screenshot generally in literature, what they have done is, on the screenshot, they have built object detection models to extract or to create a bounding box around the clickable elements. But this again could be noisy because the bounding box creation may not happen always on the clickable elements. It could be some text or some image which may not be on clickable. So this actually has all the challenges, and what we understand how to conquer all this one. So accordingly, we have developed the pipeline, which we'll present in the next slides. So our main contribution is basically, first of all, integrating RAG so that we can you can utilize our all internal knowledge database and just scan through it and come up with the process. Then, since, as I said, like this HTML parsing is very noisy and it could be error prone, So we have developed a pipeline for XPath extraction, which extracts only clickable elements using the JavaScript. And now, instead of object detection bounding boxes, we create bounding boxes on these clickable elements where there is no CV involved. And these are very robust because it is now getting information from the HTML parsing through the clickable elements. And basically, all these bounding boxes we create as a set of marks prompting because it has a unique identifier. And wherever it is on the page, LLM can directly say that go and click on here, even if there are two similar or even the same name elements on the web page. And to reduce the hallucinations and increase the robustness of the operations, we have kept the possible actions for the LLM to be very limited. So for example, just scroll down, enter the text, go back, and like that. So this is the overall agentic workflow. So the user gives the query, which is the natural language. Then we have split our agent into two parts, the planning stage and the execution stage. So in the planning stage, basically, another thing is now because we have split this into two, we don't have to use large vision models always for all the steps. We can even rely on small language models, and then execution stage can rely on the vision models, which could be little costlier than that one. Then the execution stage, we actually have the observation space, which we'll discuss what is observation space, action space, and then how are we integrating multimodal vision models on that one. So we have kept the analogy slightly similar to the reinforcement learning so that it can have easy way to understand what we are actually doing. So the agentic flow detailed, I'll just introduce on that one and then I'll hand over it to Varun. So as I said, the user instruction comes as a natural language, which is given to the planning stage. Planning stage is a language model, text-based model, and it also has the RAG integrated on the internal documentations and the LLM knowledge itself. So that from that, it basically generates the plan, like to carry out this task, what could be the number of steps to be followed, kind of following a tutorial to complete that task. Then it gives this task to the execution loop. So, and yeah, so basically to carry out all the stuff, we are using the Selenium so that it operates in the background to operate the web operations. So the first task is basically to extract all the XPaths using the JavaScript bits tool, and it extracts only for the clickable elements. And then all these bounding boxes and the IDs, we just create these bounding boxes on the images of a snapshot. And accordingly, we also create this data frame where the ID and corresponding XPath is mapped so that it can be referred during the loop anytime it wants. This is the observation space, is basically the HTML parsing or the ID what we have created, and the snapshot with all the bounding boxes which we have just got it. And this bounding box creation and the XPath extraction, it happens for all the pages. If you go to the next page, it will just remove all the bounding boxes. It will remove the table. It can store it in the memory, but for that task, it will remove the table and create a new one for the next web page. So this information is basically always the latest and updated one. So like I said, the action space is very limited, just like scroll up, down, enter text, and like that. And we basically send the snapshot with the bounding boxes mounted on those to the large language model, and accordingly the task comes and then it just gives you the ID and the set of action to be performed. So for example, click on ID number 21, and then for that ID number 21, we again refer back to our data frame. We extract that XPath, and that is given to the Selenium to carry out the task on that one. This basically loops continues. We also added the reasoning and reflection in that one, so that it doesn't just keeps on running for a long time. If it finds that it's not going anywhere or it just not working well, it just stops and just tells the user that the action is not completed properly. And at the end, when it gets the end signal, it just stops and whatever is the output is shown to the user, like applied leave or maybe filling up some task in that one. Okay, I'll call Varun for explaining the next components of this pipeline.
Hello. My name is Varun, and I'm going to explain you the methodology about the knowledge hub. So basically, we took the documentations of all the internal web pages that are present and fed it to the RAG and extracted out the steps that are present to maybe apply a leave or fill in a frequent feedback and all the steps that converting the um, making a LLM reason about the steps and everything, and we have created a normal text file about it. After that, the bigger issue was clicking on the right element, because most of the things, the complications what I was facing while working on that was, there were certain things that were as an image component or something else on the web pages, but while going deep inside the HTML pages, that were represented as a different terms inside. So I could not just send the image to LLMs and tell them to generate a Selenium code to click this or that. There was a lot of times that I was facing issues. So this was my pipeline to get the XPaths, because XPaths are kind of addresses where you can find what element is located, and it is always correct. It will never go wrong. So what I did was, I set out the bounding boxes, as Gaurav explained, that every clickable element has a bounding box with a unique ID around them, and we used to send that screenshots with the reasoning, with the planning stage to the large multimodal to give the next step and the reason why it is choosing that action and performing that action. So if you can yeah, so these are the XPaths and the IDs that are over here, with the bounding boxes around them and with IDs. So when I send this image to the LVM, it outputs me with the next step what I have to do with the action. So I have given the LVM of set of actions that we have, that is either click, enter a text, or scroll up or down, or go back. That are five action spaces that we have, and I've kept it limited, because otherwise it was generating random Selenium code and it was most of the time hallucinating over there. So these are the action spaces that I have inside the agent that it performs. And yes, so this is my prompt. Basically, I am entering my previous response from the LLM. What did it click? What did not click? I'm asking the LLM to fill the next response that I have. I have sent it with the action space. If there's some input that I need to take from the user regarding some entries, I have prompted the LLM to write me a Python code about it and create a UI, so the user can enter the data over there, and no data that user is entering goes back to the LLM, as I get the text and it directly goes to the Selenium API to enter. It never goes to the LLM if it is a password or anything. It never goes to the LLM. And also I have the task over here and the planning steps that we generated in the starting appended in this prompt. And the next prompt over here is, once we have created a step, the action has been taken, I take that observation back again and I keep my previous three observations and I give it back for reflection, asking the LLM for the step that it took. Is it right? Is it wrong? Or if my task is finished. If it is wrong, can you please tell me which is the right step I should go back to, so that I don't waste my time going deeper into the HTML DOM tree where I'm not going to find my solution. There have been a lot of times while I was trying the open source frameworks, this was a bug where people were where the codes were just running inside, and we were not reaching a meaningful output after that. Yeah, this is a first demo that I tried was on a Google website to turn the dark mode off on in a different language. It was not English, so it did that. And there was another where I was applying leave, and it was able to apply leave on the workday. Now, what RAG was doing, so there's this point where I'm not using any hints right now from the internal data source that I have provided as a RAG. Over here, it went to a web page that was not associated to leaves. And while using the reflection prompt to ask LLM if it is leave or not, it gave me the output where I'm wrong, I'm going wrong into the DOM tree. It is wrong, I should go back 2 pages, because right now where we are going, we'll not find a leave application. And there's another example where I did that and we went to the leave. So one thing that I have found, the on the state of the art right now, the accuracy with all the operators I don't know, but when the computer use came, computer use accuracy was 23% on the task what it was performing. And if you are going specifically for the web page operations, it was around 40%. Once I had introduced RAG with hints giving what the next step can be, how the processes are done, the accuracy increased by 20-30%, and my leave applications and frequent feedbacks 2 three main objectives that I was focusing were going on smoothly without any error. Yeah, so three, four things that I feel I improved on with the open source frameworks that were present. By introducing the reflection, I stopped LLM going deep into the DOM tree and wasting a lot of tokens, because while I'm sending a involves a lot of things inside, and there was a huge token cost that was involved. And secondly, I had kept the exploration in a HTML page till only 10 steps. If you are doing a task, a user task, that is something on a psychology level, that a task will not go down 10 steps and it will finish. So I have kept it on 10 steps, and if I get stuck on any error, I had given it only 3 tries to retry it again, check if it can be resolved by going back or not. And we were ending the task over there by giving the task would not be concluded. Uh, Otherwise, yeah, that's it. With the RAG, we increase the accuracy.
Yeah. So just to summarize, so we actually, our objective was to build a stable system, because just to avoid the hallucination and randomness which may come by by forcing LLM to generate the entire Selenium code. So that was our objective, to keep it as minimal reasoning possible from the LLM as possible, and just to keep all the possible errors away from the LLM. That's what we did. We we integrate the XPath extraction into that one and set up marks bounding boxes, which actually increase the stability, so that pinpointing which element to be clicked. So that was the useful addition. Like Varun explained, the reasoning steps were added. The screenshot of the bounding boxes were helpful. The set optimals were purposefully kept very minimal, so that LM is restricted to choose it from them. And a reflection is added just to avoid any long iterations, which we may encounter in the erroneous explorations. The main limitation what we observe currently is in the scrolling, and what I mean by scrolling is not on the main web page, but sometimes if the widget comes on the main web page, on that, if there is a scrolling, I mean, we were struggling at the beginning. So if it is without scrolling and just entering the data or clicking, it was working well. But if there is a scrolling on top of the main page, we were struggling. We actually are working on that one. Presence of the captchas, I mean, of course, for our internal web pages, we don't have to worry about the captcha because we may not encounter there. But if it is being used for the open web pages, this is a limitation. And of course, ethically, I mean, that again, another discussion to be carried out, whether shall we use AI to solve the captcha or not. Yeah, the next, like I mean, like the previous talk, we actually can integrate these IT tickets, issues, and their resolution as a document for the LLM, so that it can use that information also to solve some of the tasks which is it given to. Yeah, thanks. That's all.
We can take one or two questions if you have any.
Regarding question is regarding that you are kind of doing the Selenium work, right? That
Yes.
Is it not a solved problem with the Vusion scripts, and one time
So-
somebody can record the script and then you can play n number of times?
Yeah, exactly. So that is more on the RPA side, robotic process automation. So what happens is that you can record the steps, so that becomes very static. So some of what happens is some of these web portals we actually observe every like 3 months, 6 months, or even 1 year. They keep on updating, and sometimes the Leave application is only the example what we have shown here. But apart from that, many of the agile tickets, it could be variation in as per the user query which can be applied. So there actually this task is more useful. than this one.
Here also I see a lot of tight coupling, right? So you have a object detections, you have a boundary conditions. The moment I change my UI, things
Yeah.
will go haywire, right?
Yeah, so the
Because-
object detection is purposefully removed from this one. Whatever the bounding boxes are created, those are from the clickable elements and not from the computer vision object detection model. So even if the UI changes, when we parse the HTML, we exactly get which are the clickable elements on the entire web page. And we create the bounding box on top of them with the unique ID. So that's how it knows where to click and which is the clickable
But the
element.
sequence of clicks would change.
That's fine. So that kind of information should be available in the documentation. From there, it will extract. So
RAG will work there.
yeah, we actually have observed it works.
Thank you.
I was trying to understand their workforce. One thing I understood, that everything they have to give steps for it. They have to predefinedly tell that here is the X path or here is there. But the change what I noticed can be influential was, while every HTML page has the HTML code, and I, as a specific, we were creating divisions around the clickable element. So it does not matter if you are giving the paths or not. It's on the LLM's reasoning capabilities that if it can identify, or if you have the documentations to carry out that next step is this, or LLM can identify the next step is this, then your workflow is keeps on going on without even if the UI changes, it still keeps on going on because the logic of your workflow will never.
That is correct. That's a different thing that you have created, because you are analyzing the page right at the moment,
Mm.
not like you have stored it somewhere, unlike RPA. So you have passed that thing. But what I wanted to understand is, on the commercial side,
The cost.
have you tried to map it to, okay, some other vendor costs this much for this much clicks on this, and this is how the computer runs for this much amount of time? Any sort of analysis that you would have
No,
done? Because
currently not.
obviously there is a huge cost for this picture tokens that you send, and you are sending some RAG related data also,
Yes.
again and again for every interaction that happens.
Yes.
So obviously the metrics can be created around it. So I was just interested if you have already done so.
Yeah. So actually, one addition on that one is, since we have kept this vision model and the language model separately, for the RAG, we are actually trying with the one of the open source model mounted in our own system without any GPT uses for that one. And only for the vision, we would be relying for the GPT models.
Any research you have done on the vision model being open source and being locally deployed during this
I
stage?
actually tried that, but there's this paper set of marks prompting that actually told me that if you provide a semantic knowledge with the image, it gives you a better response on a relative angle. But while I tried the same set of marks prompting on the open source models, I could not get that output back again. So it was hard to get that same thing from the open source models compared to what GPT was doing.
Thank you.
All right. So that brings us to an end to this session. Thank you, Gaurav.
Thank you.
Thank you so much.